Okay, all right, awesome. I'm a Healy Hazelton, 403 to the HAZ. In the house here. And we are talking about domain and range, okay? This is part 2, and we're just gonna kind of iron out all the little details here. So, we know that domain is basically the values of x within which my function will live, okay? And my range is the values of y within which my function exists. We had, I guess, really 2 types of charts that we'll see. Continuous data, where there's the data points, there's connection between them. So you could think of, you know, if my x-axis was distance and my y-axis, or my x-axis was time driving and my y-axis was the distance I've gone, well, after 2 hours I might have made it to 100 kilometers, but I can travel fractions of the time, right? So at 2.5 hours, I'll be somewhere in between these 2 data points, right? So there's data that exists between the data points. That's continuous. Data exists within data points. The other is discrete. So continuous is values exist between data points. And then, so discrete means that, for example, if I am selling I use the Girl Scout cookies, okay? So if I can't sell a fraction of a box, and I'm looking at how much profits I make. Well, I can either sell 3 boxes, or I can sell 4 boxes. And at 3 boxes, let's say it's, I'm making $5 profit per box. So if I sell 3 boxes, I've made $15 profit. But I cannot sell a half a box to get to like $17.50. It's either $15 at 3 boxes or $20 profit with 4 boxes. Or if I go down the other way, at 2 boxes, I'm making $10. There's no data in between those points because I cannot sell half a box. So that's an example of where it's discrete. And there's a lot of different examples, and you'll see them in the problems that you do. So that's discrete, okay? I think that's no values exist between data points. Okay, so let's actually start talking about some types of charts, or let's actually start doing some domain and range, because now we're going to talk about the 2 ways of really representing domain and range. So I'm just going to make a chart right here, so we're going to go through that point, and then we're going to end right here, and then this is going to go, we'll say, to there. Okay, so here's my chart. It goes like this. Okay, and I say, what is the domain and the range for this chart? Okay, so we know that domain is my x, the values of x within which my function exists. So my function exists in between -4 and 6. Now, when a dot is empty like this, it means not including that number. So it's up to 6, but it's not 6. It can't be 6. It can be 5.999, but it will never actually hit 6. So that's not including. And then when my dots are filled in, it means including. Now, the textbook actually doesn't get into the 2 different types of dots. So you're going to always assume, it seems, that it's going to be including. So let's do something like this. So the domain. So the first way that I can represent domain is basically just like this. So the first way is open my squiggly bracket, and I can say my x values such that, my x exists such that I am between -4, including -4. So I'm between -4 and I'm greater or equal. My x's have to be greater or equal because it's filled in to x. and then x has to be smaller. It can't be equal to 6, just has to be smaller than positive 6. And then we always finish it off with x is a real number, because we can be anything along, because it's continuous, so it's anything along there. The other way I can do this is using brackets. Now, the only thing we need to know is I'm basically going to, how to explain this? So if I use square brackets, so this is going to be the low end. So I would represent this one like this. I'm going to show you right now. I would say -4, comma, 6, round. A round bracket means it's not including this number, and the square bracket means it's including this number. So basically it's saying we are going from -4, including -4, all the way to 6, but we don't include 6. So square brackets mean we include that number. Non-square brackets mean we don't include that number. Round brackets means it's up to that point or from that point, but not including that. So that's the two ways we can represent the domain on this function, is -4 to 6. And on the range, aka what are the values of y within which my function exists? I'm going to check that I'm still filming. I'm still filming, good. Is the same thing. So squiggly bracket, y such that. Now my y exists between this on the bottom and this is my max here. So from -2, and it's including -2, up to 2, but not including 2. So we go from -2, and we can be greater or equal to -2, y, but y has to be smaller than 2. So it's in between -2 and 2, where it can be equal to 2, but it cannot be equal to positive 2. It can be equal to -2, sorry, but it can't be equal to positive 2. So that's why, like that. And then y again is a real number. This is basically going to show up almost every time at the end. It's not imperative, but it's good practice. And then again, so I can include -2. So I'm going from -2 inclusive all the way up to positive 2 not inclusive. So there's my range. These are the two ways of representing it. Okay? So let's do another example. Now let's do one that doesn't actually have any finite end. What do I mean by that? Well, it's going to go on forever in the x direction. So let's say it looks like this. Here's my graph. It's what we call a quadratic, okay? Let's say let's do two versions of this one first. Let's do one where we go all the way up to 4. There. And actually we'll go there. We'll go to there. Let's say we go something like that. That is ugly. Wow. But it's good enough to do a domain and range with. Who cares? Let's just say that this point up here, these points up here are at 4, and it hits the bottom at -2. Good enough for me. Let's do the domain and range. So I'm going to just erase what's in here. Okay, domain. What values of x does my function exist within? Well, it exists within the extremities, which are at -4, not inclusive, up to +4, inclusive. So I would say, okay, we're going from -4, and we can't be -4, so we just have to be bigger. We cannot be bigger or equal to. We just have to be bigger than 4, so x goes in the middle, and it has to be smaller or equal to +4, because it's filled in, the dot's filled in. And then we finish it with the same thing, x is a real number. Now if I wanted to use my bracket notation on this one, I would go, so I cannot include -4 on the negative end, or on that line side, and I'm going all the way up to +4. So basically it's your lower number on the left, your higher number on the right, but it can include +4, so I use a square bracket on that side. Now let's do the range. So y exists between -2 and +4. Now, it cannot equal +4 on this side, but it can equal +4 on that side. So this is going to be my extreme on the high end, because +4 inclusive is a bigger number than 3.9999 or whatever that is, because it can't be 4. So I want the biggest extremes of values for y that it can exist. So it's going to be from a +4 inclusive, so all the way down to -2. Now, it hits -2, we just assume that it can be equal to -2. Normally, they would give you a data point down here. So in this case, I would fill in my little data point there, so we know that it can be -2. So my y's are going to go from -2 inclusive, so I can be greater or equal to -2, and I can be smaller or equal to 4. Smaller or equal to 4. And then y is a real number. And then, if I wanted to represent this with my function notation, or my bracket notation, it can be -2 on the low side, all the way up to +4, which it can be as well on the high side. There we go. Now, what would happen if this chart, instead of having a fixed end, just looks like it went on forever like this? So normally we'll show it with arrows going like that, saying it's just going to go on forever. Which means it's going to go on forever in the positive y direction, and it's going to go on forever in the x. As it opens up, it's just going to keep going forever in either x direction. So my domain, in this case, my domain is going to be any x. Because this chart's going to go from, there's no x's that it won't hit. It goes all the way, it's continuous in here, and then it goes forever. So, in that case, our domain is just any real number. And I could write it like this as well. -infinity to +infinity. Inclusive, non-inclusive, who cares? Because infinity's theoretical anyways. My range. Now my range, I can go as far as I want into the positive y direction, but my extreme my low end extreme is going to be -2. So basically, my graph is going to exist for any value of y that is greater or equal to -2. So in this case, my domain is y is greater or equal to -2, where y is a real number. As you can notice, my y is no longer sandwiched between two values because it can go as far as it wants in that direction. It's not constrained, so that's why it can be, y just has to be bigger than -2, because that will take care of everything in that direction. And then in this case, I'm going from -2 inclusive all the way to infinity on the high end. Okay? So that is that. And I think, honestly, I think that's enough to get you going. It's enough to get you going, and I don't want to ruin it. So hopefully that helps, and you can always ask questions.